I think here we are very in the beginning stages of really know how to analyze these data. And I think that was also discussed a little bit in terms of the medical record and medical sciences. And I think there is really important need here for training for that combines social scientists, probably medical scientists if we want to do health record data, but also data scientists. And I think it's really important not to bring these individuals together because each fields have specific questions they want to answer, and data scientists alone probably won't be able to integrate all the information that social scientists might be interested in, and we don't have the methodologies to really how to best utilize these data. But one of the things that's important here is that these are very easily and quickly available, or more quickly and easily available than spending millions of dollars trying to do survey data. So they are beginning to be used more frequently to try to answer social science questions as well. And they can also be integrated with other data sources. So one issue that was spent a lot of time on in the other talk was replication of findings. In the social sciences, it's becoming more common for journals to ask you to provide the code that you use to write your article so that someone can actually rerun the code on the data that you used to do your analysis, so that the replication in that sense is important. Obviously, this will slow down the review process. And this is more common in economics at the moment than in other social sciences, but it's also becoming common in demography. But there is this concern of a slow review process because people have to spend a lot of time reading the code, and sometimes very complicated code, and also getting the data. But I think this is a very important development, especially in social sciences, where mostly we use observational data. And as was pointed out earlier, depending on what variables you include in your analysis, you can get very different kinds of results.
Translation, which means taking a basic science discovery all the way to the clinic and to the community and making it work, takes a very long time. On average, it takes about 25 years. In some cases, it has taken more than 100 years. There's a few fast and furious success stories, like, for example, HIV disease. I felt extremely privileged to live the era when triple therapy was proposed, well, discovered first. You know, you had these antiretrovirals discovered like protease inhibitors, and within 4 years from discovering a protease inhibitor, reaching all the way to having a randomized clinical trial, ACTG 320, where I was involved, where we showed that you can dramatically decrease mortality in these people. And you saw a disease transformed from something that was killing every single patient that I was seeing before that to a condition that you can live pretty much a normal life with normal life expectancy. But on average, this is not the typical story. On average, we're talking about long delays, and we're also talking about situations where even when you reach the point of having an extremely influential, highly cited clinical trial, like the ones that I show you here, which are the most highly cited trials in the history of clinical medicine. These are the red points. Even at that point, you have a 40% risk of an even larger, better controlled study to refute that major seeming discovery. So there's a lot of angst about reproducibility. How many of our results can we trust? How many of our results can we move forward? Across all 22 major fields of science, there is an exponential growth in the use of terms like reproducibility of results. But each one of us may mean different things when we're talking or thinking about reproducibility. There's basically three major types of reproducibility. There's reproducibility of results, of methods, of results, and of inferences. Reproducibility of methods means that you have some software, some script, and some data, and if you mix them together, you expect to get the same result.